Okay, guys. Sorry, I had to. Um, so yeah, we're gonna do with more power roll, more negative stuff. So first, let's talk about what we learned yesterday. Let's start off with this thing. It was the idea that you had a times m in parentheses, and outside the parentheses you had an exponent. And what you ended up doing was multiplying these guys, and this became a to the m times n. So that was from yesterday. So today, what you're doing is a lot of the same stuff, except we got a couple extra rules, especially dealing with negatives and whatnot. Okay, so let's jump right in. So let's first talk about -3 to the 0 power. Okay, first thing, anything to the 0 power is 1. Always and forever, doesn't change. Anything to the 0 power is 1. Okay, so it doesn't matter what's on the inside. There's one example. You could have had a times b to the 4th times 3 to the 27th times theta to the 3rd power, all to the 0, and you get 1. Okay. 0 affects this entire parentheses. Everything in here gets affected by that 0 exponent, and you get 1 for that answer. Okay, so we should be clear on that. If you guys don't believe why this happens, here's why. I'll tell you why anything to the 0 power equals 1. So let's say you get a to the 2nd power times a to the 0 power equals a to the 2nd power. So we already have this a to the 2nd power on the left side and on the right side. It's already there. You get the same number, but there's this thing right here. So the question is, what number do you multiply to some term and you get the exact same term back? It doesn't change it. And that number is 1. That forces this guy to be 1. So there's a little bit of foundational understanding. Anything to the 0 power is 1 no matter what. Because of this rule, it forces anything to the 0 power to be 1. Because of our adding exponents rule. So back to the negatives. So -3 to the 1st power. It's -3. -3 to the 2nd power. That's -3 times -3, which equals a +9. -3 to the 3rd power is -3 times -3 times -3, which is a -27. And -3 to the 4th power comes out to a +81. Do you see some kind of relationship between the exponents and our answers? What kind of relationship do you see? Okay, I'll give you guys a little bit of time to look at it yourself. Okay, think time is up. So what you got here, okay, if you notice, 1 is odd, you get a negative. 2 is even, you get a positive. 3 is odd, you get a negative. 4 is even, you get a positive. So we talked about, the exponent being negative, which meant you drop it, but we have to talk about the base now. The base. Okay. If the base is odd, oh, sorry. No. This has to do with a negative base. Yeah. So if you have a negative base and the exponent is odd, then the answer will come out negative. If the exponent is even, then the answer is positive. So negative base, odd exponent, negative answer. Okay. That's the rule. So we'll do an example problem. Whoops. Okay. So an example problem would be like, okay. Actually, this is a good thing to bring up. Okay. There's a difference between number 9, -7, p, q, r to the 4th times -6, p to the 3rd, q to the 6th to the 0. Okay. So based on that last rule, you guys are going to look and think, okay, this answer is going to come out positive because you have a -7 and an even exponent. Not always the case. If we had parentheses around this and everything was being raised to the 4th exponent, then your answer would come out positive. But since we don't, this is like saying -7 to the 1 power, p to the 1 power, q to the 1 power, r to the 4th. That 4 only applies to the r. Okay? Whereas this guy over here, the 0, because we have parentheses, it applies to everything in here. So this just comes out to 1. And this is just -7 p q r to the 4th. Okay? Do not get that twisted. So I guess if we were to do like a general outline of how to attack these problems, okay, so we'll just talk about like a method or a strategy. Okay. 1. Distribute exponents using the power rule. 2. Evaluate the numbers. And 3. Combine exponents of terms as needed. Okay. So an example would be like if you have 2x to the 3rd times -3x y to the second power. Strategy 1 is use that power to a power rule. This guy goes to every single term in there. So this becomes 2x cubed times -3 squared times x squared times y to the 4th. So let's do the numbers now. Okay, we got 2 times x to the third. Negative 3 times negative 3 is a positive 9 times x squared times y to the fourth. 2 times 9 is 18. So we just evaluated the numbers. Check that off our list. And now we combine exponents of the terms. X to the third times x to the second, x to the fifth. And there's nothing else for y, so y to the fourth is here. Alright, so let's talk about solving. This has to deal with actually, let's bring up a problem first, and then let's talk about strategy. Yeah. So let's do something like 2 to the 2x power equals 16 to the fourth. And you're like, what? So when you see this, we got to think about this property. The property says if a to the x equals a to the y, then x equals y. So if the bases are the same, the exponents have to be the same. But our bases aren't the same. We got to fix that. Okay. So what we're going to do is we're going to focus on the 16 right here. And we're going to rewrite it as a power of 2. So on the left side, 2 to the 2x. On the right side, 16 is 2 to the fourth power to the fourth. Okay. These guys stayed the same. Okay. The only thing that changed was this part right here. I just changed the inside, the base, into a power of 2. Okay. So on the left, you got 2 to the 2x. On the right, you got to use the power of a power rule. 4 times 4 gives us 2 to the 16th power. And now we can use this rule that says if the bases are the same, the exponents must be equal. So exponent time. So we just say 2x equals 16. Don't even have to worry about the bases anymore. All we're doing is worrying about this thing right here. Divide both sides by 2. X equals 8. Okay. And that's how we solve this thing. And yeah, that's pretty much it. Don't forget the video. And don't forget to fill out the form. And with that, I guess we'll say bye.